Alright, welcome back for the second chapter of today. This will continue on with DHCP, but we'll be looking at version 6, which uses SLAAC, which we'll discuss what that is during the course of the chapter. So we'll be looking at how DHCP version 6 works and how it uses a couple of different methods for assigning addresses out to clients and how we configure the devices to have these operations work. So, global unique addressing assignment is what we're all about with DHCP. So we all know that we can assign addresses statically, and we do that via the screenshot there, which is just typing in the IPv6 address and the subnet prefix length, the default gateway, and our DNS server. Now, as per v4, this becomes very time consuming and it's not the most efficient way for us to do addressing management within a network. So just to remember that IPv6 has a local link address as well as a global unique address. So the local link address is automatically generated whenever the host boots up and has an active interface. And you can tell this link local address by its starting prefix of FE80. So that indicates that it is a local link address, which means it's not routed. It's used to control messages within the local link. So we have two ways of assigning addresses, stateless and stateful. So stateful, the server and the stateless. So we'll be looking in detail of these two methods, but you can see there from the graphic that we have two methods under stateless, which uses SLAAC only or SLAAC with the stateless DHCPv6 offering working together, and then stateful, which we are using the DHCPv6 stateful mode, and we'll look at these different methods as we go through this chapter. I'm not going to go through it all on this slide. Kind of defeats the rest of the chapter if I do that. So let's go through and look at these things as they come up. So our messages work a little bit different in the v6 environment. We have our ICMP RA messages, which, if you remember, is an advertising message, and within that we have a few different flags to indicate what's going on. A, O, and M flags. So we have address auto configuration flag, which is stateless address auto configuration, which is SLAAC for generating the global unique address. We have the other configuration flag, our O flag, which gives us additional information under the stateless configuration. and manage address configuration, which means we're using a stateful DHCPv6 server to do our addressing. So there's a few combinations of those flags together. That means we can control how our devices are getting configured. So look at SLAAC to start with. So we don't need a server for every device within a network to get a unique address. We can use SLAAC under stateless addressing to produce a global unicast address or a unique address, depending on which bit of material you're reading. The stateless service means no server needs to be maintained to keep track of addressing. We're going to use the messaging methods for route solicitation and route advertisements, which basically happen every 200 seconds, bouncing around the network to auto-configure our hosts. And we can deploy a SLAAC-only method, or we can use it combined with a server to control our addressing. So SLAAC is basically on when you configure your device, and you can have a look here that as soon as you start up an interface, it's going to assign the IPv6 being turned on. You'll give it a link local address. You will give it a global unicast address, and it will join the all nodes group, which is FF02::1. So we know that this will start giving addresses out automatically. Okay, so all we need to do is turn IPv6 unicast routing on globally on the router, and those route advertising messages will start being sent using SLAAC. So routers belong to the FF02::2 group of messages, not the all group, which we saw on the last slide. The all nodes are a different group, so it will listen to the all nodes, but the have a different groups in IPv6 to communicate between host machines and routers to routers. I believe we went through that when we went through IPv6, so I won't spend that much time here. So our rate advertising, so the number 1, so flag value, informs the client to use an IPv6 GUI prefix in the route advertisement and to dynamically create its own interface ID. The O and M flags are set to 0, which means it's not going to use additional information. So if you look at the flags, we can tell what information is going to be sent out under those optional things. Because remember, the M is telling it to use a DHCP server. So if we're just using SLAAC, that's got to be off, because it's not attaching to a server. So use the ipconfig command to confirm that the addresses have been created on your local device, and you should have an FE80 and a 2001 DB8 address as shown here. Notice that the default gateway was on a local link address, an FE80. Gets that from the route advertising message sent out by the router. So the route solicitation message is sent out by the device, and a route advertising message is sent from the router to the device confirming this method. So in this case, we're sending the RS message to the router. The router is responding saying to initiate the SLAAC method. And SLAAC, tells it the prefix of the network address, so the subnet information, and it tells it to generate the remaining 64 bits of the local interface ID, and it can use either a random generated 64-bit interface ID. This is the method used by Windows 10 hosts, or it can use a UE64 method, which it uses the device's MAC address and inserts FFFE into the middle of that MAC address, converting it into a unique 64-bit interface address. Now, either method is valid, and you can do it. Now, there's some, concern that the MAC address can be spoofed and all that. As soon as you've got messages in open format, those messages can be spoofed. So machines can be impersonating other machines. This is why we have man-in-the-middle attacks and so forth, and we need mitigation methods to help resolve that. So just be aware, the same security issues that were around in IPv4 can be around in IPv6. It hasn't resolved all the issues. Duplicate address detection is inbuilt into SLAAC with the DAD function. Yes, all those dad jokes can come into play right here, right now if I wanted to, but I'm not going to do it today. I'll do it later. They come off better when we're doing face-to-face classes anyway, rather than remote. Excuse me while I have some coffee. Can't do networking and coffee. Those two things have to go hand in hand. If you're not a caffeine intake person by a coffee, I'm sure you've got your other methods of getting your caffeine. So when we get a unicast address, we need to make sure it's unique, and that's why I continually keep interchanging global unique address and global unicast address because it's a unicast, but it's got to be unique. So that's a common thing that I do. Apologies if I confuse you by doing that. Okay, I got in the habit of that because I've got to stress that these global addresses have to be unique, because these addresses are live addresses across the world all the time. So every address needs to be unique, and this is how that came about. So The host sends a neighbor solicitation message out, and it's a multicast address containing the last 24 bits of the host address, and the device's neighbor advertisement messages. If no device replies with its own neighbor advertising message, basically says, well, nobody is using that address. It's kind of guaranteed, but gives you an idea that we've got the chance of having a duplicate because it's only the last 24 bits, not the last 64 bits, so you can have some duplication occurring. Okay, so as they try to stipulate down the bottom, we've got a 64-bit interface ID, which is 18 quintillion possibilities. So we're getting fairly low in the order of probability that we'll have a duplicate address. Not going to say that it will never happen. Random number generators will occasionally generate the same number. But the chances of it happening on the same network within the same lease time, well, that greatly reduces it again. Okay, so DHCPv6 operation steps in a stateful environment. Does not require SLAAC, while stateless does. So the way this works is when the host sends the route solicitation message out, the router responds with a router advertisement message, which basically tells it that the DHCP server is located at this address, and it sends a solicit message to the DHCP server. The server responds with an advertised message. The host responds to the server with the request, and then the reply from the server locks in the lease. So it's not much different from V4 in that the operation is the 4 messages, but how it gets there first is a little bit different. So because it's a V6, it sends out the router solicitation message to find out how it's going to be dynamically assigned, and the router advertisement message tells it it's going to talk directly to a DHCPv6 server, and then it goes through the 4 steps to get an address assigned from the server, just like V4 does. So these are slightly different port numbers that V6 work on, so it doesn't get confused with the V4 request system. And so it's using 546 and 547 UDP ports. Stateless. So when the route advertisement indicates a DHCP stateless method, the host uses the information within the advertisement to contact the server and then gets cracking. Alright, so it's not that much different. It's still using the same information, but it's using it from the advertisement. So it's going to, it's basically generating the information, but in a slightly different method. So let's turn it on. IPv6 on the interface that you want IPv6 to run on, and you use the command nd other config flag, and this will set the O flag to 1. So this is telling the interface that it's going to use stateless DHCP on that interface. You can put no in front of this command to remove it, just like with every other command. Again, if the DHCP server is in Stateful, it maintains a list of all bindings of the addresses being used, and the PC uses the solicit message to seek additional information from the server rather than the router. So to force the stateful configuration mode, we go to the interface, IPv6 nd manage config flag, which forces the flag end flag to go to 1, which means we're going to be in a stateful configuration for DHCP. So cast your mind back to the very start when we talked about the combination of flags that we had. We had 3 effective types of address. We had SLAAC under stateless, and then we had SLAAC with DHCP under stateless, and then we had stateful, which we went straight to DHCP servers. And this is how we configure those flags to force the way we want the device to configure itself with addressing. So the router roles within V6, just like we have with every other option, we have the ability to make the router a DHCPv6 server or a client or a relay agent. As I said, it's not really that much different from V6 to V4. The basic concept is the same, so the functions are pretty much the same, just the way we go about configuring it. Obviously, we need to make sure IPv6 unicast routing is on globally before we can do any IPv6 commands. Excuse me, from the router's perspective. We then ensure that we provide the pool name, just like we did in IPv4. And I'll reiterate here that the differences in commands will be basically wherever we used IP, we now put IPv6 to change it from IPv4 to V6. So we create the DHCP pool, give it a name. We then go in and configure the DNS server address, the domain name, and we can also manually bind things together here. Okay, so bind the interface to the pool using the DHCP server pool name. So this is telling the interface to use the pool. So whereas in IPv4, we use the network command to identify the pool from the address. So when a discover broadcast was sent in, the network interface address would be used to determine which pool to use. IPv6, we don't have routing protocols running in global mode. We have them engaged on an interface by interface mode. So we've got to engage our DHCP pools on a per interface mode, just like we do with the routing protocols. And this will become more apparent as we do more labs in IPv6, because we've changed the way we associate each interface with the network addressing. So you'll develop an understanding as we go through. The unicast stateless configuration, so we enable IPv6 unicast routing, and IPv6 local link addresses will be created on all interfaces as they are turned on. So we enable them with IPv6 enable on the interface, and Cisco operating system uses the UE64 method to create a unique address scheme. If we want the router to use SLAAC, we use IPv6 address auto config command. We verify the settings using the show IPv6 interface brief command, and we can verify the messages being received with the show IPv6 DHCP interface and specify the interface that we want to see the messages for. Remember, we are assigning DHCP services by interface, so we need to specify which interface we want to look at for the DHCP. Under Stateful, we're telling it to use IPv6 again. We're giving it the DHCP pool name, and we then configure its common options as per the address prefix. We bind the pool to the individual interfaces that we want to have running DHCP services on. And remember, we have to manually set the M and A flag with the managed and ND prefixed. Okay, so we're going to tell it what it's doing. Verify using the ipconfig all command on the hosts to make sure they're getting their addresses pumped out. So basically, I know this is a little confusing, or what I can say is do the labs, take your time, and you'll see how these different methods can be used to get a different result. Is it really a different result? It's just a different method of getting to the same result. So we basically have three methods that we can push IP addresses out to our clients within the network now. So if you look at it from that perspective, DHCP version 6 is more flexible than what version 4 is. Okay, so show IPv6 DHCP pool will give us our pool name, the network prefix, how many of those are in use, what the DNS server is, what the domain name is, and how many active clients we have using the DHCP pool. So if we look at the bindings, it'll list each individual client with the link local address and what its unicast address is. It'll also give you the lease time. So it gives you the same type of information as IPv4 with bindings. As per v4, we have a relay, so we can relay those offers and so forth through our local router to our DHCP server, being that another router or a dedicated server, by using the IPv6 DHCP relay, and then we specify the destination and its address and its interface. So we need to put in a little bit more information. So we put in the server address, the egress interface. Alright, so we're basically saying this is the server address you need to go to. You'd go there via being forwarded out of this interface. So we're saving the router from looking up and determining where this network is connected to. What we're saying is we pick up any of the ports that we relay, send it out this interface to this destination. So we've basically given it all the information it needs, just repackage that IP header and send it across to the destination as part of the relay function. So this show IPv6 DHCP interface will tell us which interfaces are doing what. So here we've got Gigabit Ethernet 001 is in relay mode, and show IPv6 DHCP bindings. Well, we've seen that command before. There's the client address, link local, and then its unique address with its lease times down the bottom. I think I've said it enough during the presentation. Do the labs. The labs really help you understand all the different types of methods, and you can use the simulation mode in Packet Tracer to see the messages being generated and sent back and forth. So it really helps you cement the concepts and how it works within the environment. Because I know the theory is confusing, because you're basically going over the same things over and over, but with a slightly different twist to get the 3 different methods. All of them require IPv6 addressing to be turned on globally, and then depending on how we configure the flags, depends on which method, whether it's stateless or stateful, and which method under stateless we're going to use. Whether we're not going to use a server at all, we're just going to use auto configuration using SLAAC with a randomly generated ID, or whether we're going to redirect it to a stateless configured DHCP server. So that we need to understand what the flags are and how to configure them to get the method that we want to use in the network active. We then went through the various configuration commands to make sure that those methods can be obtained, and then we looked at the verification commands using the show IPv6 interface and the IP config on your hosts to confirm that your configuration got pushed out. We talked about the fact that the address can be randomly generated for the last 64 bits, or a UE64 method can be used, which is what's used on Cisco's interfaces by default, and the fact that Microsoft uses the random generated and Cisco uses the UE64 is there. We talked about the DAD method of ensuring that each address is unique and that the ICMPv6 messages are used to keep track of the addresses and what's being used, what hasn't within the DAD function. We had a look at the UDP ports 546 and 547 for use under DHCP version 6. And then we had a look at how we can configure the O and M flags so we can specify the configuration method that we want to use. We also had a look at how we can turn on the relay agent for DHCP, which is slightly different to the way we do it in v4, and the command structures used to verify that the relay is working. And that brings us to the end of this theory. Again, I will strongly recommend that you complete all of the lab material to get a better understanding, and I would recommend and encourage you to use the simulation mode in Packet Tracer so that you can see all these message types being generated and sent back and forth between the clients and the servers and the routers, so you can see it happening under simulation to help you cement concepts, because I know the theory is a little rough to get your head around. It wasn't until I did the labs and did it this way that it sort of cemented in how this process works, and the fact that we've got 3 methods we can do in IPv6 to get our dynamic configuration happening. Okay, so we basically had a dynamic configuration or not in IPv4. So it was either DHCP or manual. Here we have manual, and we have a couple of different ways of getting the dynamic functions to work. So we can do stateful like a traditional DHCP server works, or we can do a dynamic configuration under stateless, which we can use SLAAC just by another method and not use DHCP at all. So it really is a different way of using addressing in this IPv6 environment. Explore, have fun. Next week we will be doing the next chapter. And of course I have chapter 9. Let me just quickly bring it up here. Is FHRP, which is our first hop redundancy protocol, which is an interesting protocol in and on itself. It's very quick and easy. It's 18 slides, so the presentation for next week is going to be very sweet, short, and have fun doing it. Alright, let's end that here.